We experience time as a linear progression, a steady march from the past, through the present, and into the future. But what is time, really? Is it merely an illusion? A construct of our perception? Physicists define time as a dimension, much like space. This concept, however, is where our everyday understanding of time begins to unravel, leading us down a rabbit hole of mind-bending physics. Could we one day build a time machine and bend the rules of time? The answer, tantalizingly, is maybe. While time travel remains beyond our current technological capabilities, some scientific theories suggest it could be possible. To understand these theories, we must first grasp the fundamental nature of time itself. Time's tapestry, more than meets the eye. Albert Einstein revolutionized our understanding of time with his theory of relativity. He proposed that time is relative, experienced differently based on your frame of reference. This might seem strange at first. As you approach the speed of light, time slows down relative to someone standing still. This phenomenon, known as time dilation, has been experimentally verified. Imagine two identical clocks, one on Earth and one traveling at high speeds. The traveling clock will show less time passed when it returns. This concept forms the crux of time travel possibilities. Wormholes and warp drives. Shortcuts through space and time. Einstein's theory of general relativity also predicted the existence of wormholes. These theoretical objects act as shortcuts through space-time, connecting two distant points in the universe. Imagine folding a piece of paper in half and poking a hole through it. The hole represents a wormhole, allowing you to travel instantly between the 2 points on the paper, which would normally require a much longer journey. Similarly, a wormhole could potentially connect two different points in time, allowing for time travel. However, wormholes are incredibly unstable and would require exotic matter with negative energy density to hold them open. Such matter remains purely theoretical at this point. Another intriguing concept is the warp drive, popularized by science fiction. A warp drive would work by compressing the space-time in front of a spacecraft and expanding it behind, effectively allowing the spacecraft to ride on a wave of distorted space-time. This concept, while theoretically possible, faces similar challenges to wormholes, requiring exotic matter and immense amounts of energy. To understand time travel further, we must delve into the concept of space-time. Einstein's theories showed that space and time are not separate entities, but are interwoven into a single fabric called space-time. Imagine a trampoline representing space-time. A massive object, like a star, placed on the trampoline would create a dip, or curvature, in the fabric. This curvature is what we perceive as gravity. Similarly, massive objects can also warp and distort time. This warping of space-time is what makes time travel theoretically possible. By manipulating the curvature of space-time, we could potentially create shortcuts between different points in time. However, the mathematics of general relativity are incredibly complex, and even slight miscalculations in manipulating space-time could have catastrophic consequences. The possibility of creating unintended time loops or paradoxes remains a significant concern. One of the most intriguing aspects of time travel is the potential for paradoxes. A classic example is the grandfather paradox, where a time traveler kills their grandfather before their parent is conceived. This creates a paradox because if the grandfather is dead, the time traveler shouldn't exist. Such paradoxes raise questions about causality and space-time consistency. Some physicists believe mechanisms would prevent paradoxes. The Novikov principle suggests actions by a time traveler would be consistent with the timeline. Other theories suggest time travel might create parallel universes or alternate timelines. Changes would create a new branch of reality, leaving the original timeline intact. While time travel continues to captivate our imaginations, it remains firmly in the realm of science fiction. The technological challenges and theoretical hurdles are immense. However, history is replete with examples of seemingly impossible ideas becoming reality through scientific advancement. The quest to understand time travel pushes the boundaries of our knowledge and forces us to confront the fundamental nature of reality. While we may not have flying cars or time machines yet, the pursuit of such fantastical concepts drives scientific progress and inspires future generations to unravel the mysteries of the universe. Perhaps one day, time travel will transition from the pages of science fiction to the realms of scientific possibility.